Good morning, I'm Mr. Precella, and I'm with my Math 1325 class, and we're going to work some additional integration problems this morning. And before we do that, I want to remind y'all of your antiderivative rule involving the natural logarithm function. The antiderivative of 1 over u du. Now realize 1 over u, if you wrote that using a negative exponent, that would be the same as what? U to the negative 1 du. So whether it's a 1 over the variable or u to the variable to a negative 1 power, the antiderivative is the natural log of the, we want to make sure that the argument's positive, so we enclose the argument in parentheses plus c. Remember we said the derivative in terms of x, the derivative of ln x is 1 over x. Here we're going backwards. The antiderivative of 1 over u is ln u, but we enclose in absolute values just to make sure that the argument's positive. And we're going to need that as we do some of the homework problems, okay? So keep that in mind. And here we go. I got up here this morning early and, I printed out homework number 15, and we're going to do the first 3 or 4 problems today. Okay. So this is like y'all's number 1 from homework 15. It's the antiderivative of 7 over x in terms of x. When I see that 7 over x, I start thinking the antiderivative of 1 over x, and I know that I'm going to think of this as 7 times 1 over x dx. And once I think of it like that, it falls out very quickly. The 7, the constant factor, I can just bring down. What's the antiderivative of 1 over x? That is ln, absolute value of x, plus my constant c. Realize if you said, I'm going to try to, if you don't think about ln x, if you don't think about the natural logarithm, suppose you come down here and you do this. You say, okay, that's the antiderivative. You would write that as 7x to the negative 1 dx. And then you go 7x, anti-differentiating x to the negative 1. Negative 1 plus 1 gives you an exponent of 0. Divide by 0. That should tell you right there you've messed up somewhere. You can't divide by 0. So if you try to use that power rule to anti-differentiate, you should eventually, when you wind up trying to divide by 0, you should recognize you have a problem, and then hopefully you'll remember, oh yeah, the derivative of ln x is 1 over x. Any questions there? Okay, number 2. Okay. That's a negative 4 over the antiderivative of negative 4 over 5 plus 7x dx. Well, we don't have a quotient rule for antiderivatives. There's no quotient rule for antiderivatives, so usually when we see a fraction like this, I think to myself, okay, let's try to write it using a negative exponent. Let's try writing it using a negative exponent. That's negative 4 times 5 plus 7x to what power? The negative 1 dx. So we have a quantity raised to a power. We have a quantity raised to a power. That should make us think of what? A u substitution. So I think we need a u substitution here. Let's let u equal what? The thing being raised to the power, 5 plus 7x. I agree. And then du is derivative of 5 plus 7x is 7 times dx. So that 5 plus 7x, that's going to become a u. There's only one other factor containing an x. What's the other factor containing an x that we need to get rid of? That dx, the differential of x. Well, what have we got down here? We need it solved for dx. What do we have that we don't want? 7. So our trick is to multiply by 1/7. Good. So we have 1/7 du is equal to just dx. So I'll use this line here and this one here. So the -4, by the way, the -4 is a constant factor. Constant factors take care of themselves, as we're about to see. You have the -4. The 5 plus 7x, that's going to be replaced with just a u to the -1 power. And then the dx is being replaced with 1/7 in du. So the 1/7 goes where? In front. And then the du goes over there. So we have a 1/7 du. Any questions so far? Constant factors take care of themselves. We can multiply these right now. -4 times 1/7, that's -4/7. That's -4/7. -4 times 1/7, I'm going to multiply them together to give me a -4/7 right here. U to the -1, if I try to add 1 and divide, I get zeros, dividing by 0, so what should I remember? The antiderivative of, where's that other page? Here it is. Here's what it is. Let me fold this. The antiderivative of u to the -1, that's an ln absolute value u, so the antiderivative of u to the -1, that's the natural log of the absolute value u plus c. One over u is the same thing as u to the -1. When you anti-differentiate those, you pick up that natural logarithm function. And there's only one thing left to do. Get it back in terms of x, so we have a -4/7 times the natural log of the absolute value of 5 plus 7x plus c. For my final answer. Any questions there?
When we're plugging right into the computer, is there like for the
absolute value bars? Okay, I'll punch that in a moment, okay? Let me do one more of these and then I'll stop and I'll punch these things in. There should be absolute value bars in the toolbar. Okay. One more. Number 3. Okay, number 3. Well, it's a quotient. It's not a lot of terms to it, I guess, in the denominator. We don't have a antiderivative rule for a quotient, so I'd try to rewrite it using a negative exponent. That would be an 8x plus 3 times a 4x squared plus 3x plus 7 to what power? I mean, to the negative 1. You know something? I'm going to have to write this bigger, okay? I'm a big writer. I need to write it bigger. So that's a 8x plus 3. Pick that denominator up, move it up top. That's a 4x squared plus 3x plus 7 to the negative 1 dx. What do y'all think? Do we need a u substitution? Yes, we have a quantity raised to power. This quantity right here has been raised to the negative 1 power. So we'll try letting u equal. Okay. So what is du? 8x plus 3 times the differential of x. Oh, this one fell out very nicely. That 4x squared plus 3x plus 7, that's becoming a u. And the 8x plus 3 times dx, 8x plus 3 times dx is giving me a du. So I used these two lines right there to make my substitutions. Then I'll draw this little box. I'm setting off aside that stuff there because I'm not going to use it again as I use the u substitution. As I do the anti-differentiation. Let's clean this up some. So I'm going to rewrite. I have an integral symbol. What's the only thing I had left here? A u to the negative 1 du. And what's the antiderivative of u to the negative 1? Okay, it's the natural log of the absolute value of u plus my constant c. And that's the natural log of the absolute value of 4x squared plus 3x plus 7 plus my constant c. Any questions there? Okay, I think we'll take a break as I punch some of these in for my class so they can see for themselves that, yeah, I've got the right answer here. Okay, bye-bye.